Hello friends, I am Dr. Nitisha Shrivastava. Welcome back to the control system lectures. This is Routh Hurwitz Criterion based lecture for the special cases. In the previous lecture, we had seen that the Routh Hurwitz Criterion for determining the stability of a system and how the Routh's array is formed. Now, here we will see that what are the special cases when we build the Routh's tabulation or the Routh's array. So, the special cases are the following difficulties may occur that prevent Routh's tabulation from completing properly. The first case is that the first element in any one row out of the Routh's tabulation is 0, while the rest of that row has at least one non-zero term. For example, we have the term A6, A4, A2, here we have A5, A3, A1 and A0 here. Now, when forming we get an element here, we get elements here. Now, maybe that the first element of any one row of the Routh's tabulation is 0. Now, in that case, if one of the element is 0 and while the rest are non-zero elements, in that case what happens that we cannot go ahead with the tabulation because a 0 has appeared. So, this is one case that one of the table or one of the element in the table has a 0 value. The second case could be the elements in one row of the Routh's tabulation are all 0. It means that this case is for the first element being 0 and the second case is if both the elements or if all the elements of that row become 0. That is special case number 2. So, these are the two special cases that could prevent the Routh's tabulation from going ahead. Now, if a 0 appears in the first row, then the tabulation cannot be completed because the 0 comes in the denominator of the formation of the table. So, then the term becomes infinite, as well as if both the rows or both the elements in the row are 0, then also we cannot go ahead with the Routh's array. Now, let us see what does this mean. The special case 1. Now, if a 0 appears in the first column of a row, then the elements of the next row will become infinite. That is, we cannot go ahead and the tabulation cannot continue. So, what is the solution for that? There are two solutions for that. That is, the first solution is substitute a small positive number e for the 0 and proceed to evaluate the rest of the Routh's array. For example, now we have obtained a 0 here. So, we are replacing that 0 with a small positive number, assuming a very small positive number and going ahead with the tabulation. That is, this value is replaced by a small positive number for the 0 and proceed to evaluate the rest of the Routh's array. And then we determine the signs of the first element of each row and then decide the stability. So, instead of keeping 0, we substitute the 0 value with a very small positive epsilon. The second step or the second way to obtain the solution is we are going to modify the original characteristic equation. Now, this tabulation is obtained by the original characteristic equation in the S domain. Now, the second way is we can modify the original characteristic equation replacing S by 1 by Z. So, wherever S is there, we replace it by 1 by Z and then we apply we rearrange or we get the characteristic equation in the form of S being replaced by 1 by Z, then a new set of characteristic equation is obtained with the value of with the coefficients of Z. And then we go ahead with the Routh's tabulation or the Routh's array and then apply the criterion to check whether the system is stable or not. So, this is how we can go ahead for the special case 1 if a 0 appears in the first row or in the first element of any row. The special case 2. Special case 2 is that the elements in one row of the Routh tabulation are all 0, that is both the elements are 0 in particular row. That is, because of a 0 row, the Routh tabulation, the Routh test breaks down and cannot continue. Since we are having a 0, the tabulation cannot be completed. The following methods can be used to overcome the difficulty. Form the auxiliary equation AS equal to 0, and where it is formed by using the coefficients from the row preceding the row of zeros. For example, we have here has A6, A4, A2, A0, A5, A3, A1, 0. We have certain elements A, B, C here, and we have element D here. For example, this D and E both becomes 0. That is, the entire row is now with a 0 element. In that case, what happens? We are going to form an auxiliary equation A of S preceding the row of zeros. That is, with the help of these coefficients, we are going to form an auxiliary equation. Taking the derivative of the auxiliary equation is the next step with respect to S. This gives us that TAS pi ds equal to 0. Then once we get the coefficients from this value, we replace the row of zeros with coefficients of the derivative of the auxiliary equation. Once the auxiliary equation is obtained, then we take the derivative of the auxiliary equation and equate it to 0 and obtain the coefficients. The next step is to continue with the Routh tabulation in the usual manner with a newly formed row of coefficients replacing the row of zeros. Next is interpret the change of signs if any of the coefficients in the first column of the Routh tabulation in the usual manner. So, this is how we can come over or overcome the difficulty if the entire row has 0 values. Now, in that case, if the entire row has 0 values, we are going to look at those coefficients preceding the row of zeros, form an auxiliary equation, then take the derivative of the auxiliary equation with respect to S and substitute the coefficients of the derivative in the row of zeros and then proceed with the Routh tabulation. This is the solution for the special case 2. Now, let us take one example related to special case 1. This is the characteristic equation s raised to 5 s raised to 4 plus s 2s cube plus 2s square plus 3s plus 1. So, we had two ways to overcome this difficulty for the special case 1 when there is 1 0 appearing in the first column of the Routh array. Okay. So, we are going to firstly form the Routh array. The highest is s raised to 5, this left side is for the reference, this is the Routh array. Coefficient of s raised to 5 is 1, this coefficient is 1, the coefficient of s cube, the coefficient of s, then this value, the coefficient of s raised to 4, the coefficient of s raised to 2, and this 5 is replaced, the coefficient A naught. So, the next is 1 into 2 minus 1 into 2 divided by 1. So, this is resulting in 0 term. Now, when this is a 0 term here, what happens to the next term? For example, if we are using this 0 into 2 minus this value upon 0, then it is infinite, we get an infinity. So, we cannot go ahead with the formation of Routh's tabulation. It can be seen that the first element of the third row, that is this row, has become 0. So, we cannot go ahead with the tabulation since we will get a value of infinity. Therefore, we are replacing 0 by a small number epsilon. We are replacing the 0, this value is been replaced by epsilon, and then we go ahead with the solution. Now, what happens if we go ahead? 2 into what will be this term? Okay, this is directly obtained from 1 into 3 minus 1 into 5 upon 1. So, we get a minus 2 here. This sign is not bothering us because we have to only check the elements of the first column. So, replacing 0 by a small value. So, what will be this term? This term is obtained by 2 into epsilon minus 1 into minus 2 upon epsilon. So, we get it as 2 epsilon plus 2 upon epsilon. So, this is how we get the first value. Then this is obtained and we get this value as 5 into 3, right, and upon this we get this as 5. And what about this term, the first element? It is 2 epsilon plus 2 upon epsilon into minus 2 minus 5 epsilon divided by 2 epsilon plus 2 upon epsilon. So, this is this quantity. Now, here and then continuation we get this value as 5 because this into this minus this divided by this, we get it 5, right. Okay. Now, what about the location, what about the sign changes, and how is this obtained? This is obtained by checking whether there are any sign changes in the first column. So, how is this done? Because we had replaced a 0 by epsilon, what we do is, now if this is a very small value, this quantity, if it is a very small value, will always give a positive result. That is, this term when epsilon tends to 0 will always give us a positive value, since it is added here positive and divided by a positive number. Therefore, this term will always be positive, right. So, this term will always be positive. So, there is no sign change, this is a small positive number and this is also a small positive number. Now, we are going to set the limit to 0, epsilon tends to 0. When you put epsilon tends to 0 here, what we get? 0 and this is 0. So, we get it as minus 4 by 2, it is minus 2. So, this is obtained by the limit epsilon tends to 0 minus 4 epsilon minus 4 minus 5 epsilon square upon 2 epsilon plus 2. So, this is how we obtain the minus 2 value here, and we can see that it is a negative number. Similarly, obtaining this we get it as 5. So, this is a positive number. Now, here we can see that there is, because this is minus 2 into 5 minus this upon minus 2. So, we get a positive number, numerator and denominator both has a negative sign. So, we get a positive. So, there are two sign changes, this is positive, this is negative, and again this is positive. So, the first element in the fourth row is this, and it will always have a positive value when epsilon tends to 0. The first element in the fifth row is becoming minus 2, and then there are two sign changes and hence the system is unstable. So, we replaced epsilon by 0 by a small positive number epsilon and went ahead with setting the limit epsilon tends to 0 and obtaining the check. Remember, we are not interested in the actual value of the first element. Here we are interested to know whether the first element of the the elements of the first column, is there any sign change. So, that is the main purpose here, to check the stability of the system, and hence we can see that there are two sign changes, and hence the system is unstable, having two poles in the right half of the S plane. We are checking the same numerical, that is the same example using method 2. In method 2, what we had to do? Yeah, modify the original characteristic equation replacing S by 1 by Z. Now, replacing S by 1 by Z, yeah, we are replacing S by 1 by Z. So, all the terms which are S here becomes 1 by Z. So, this becomes S raised to 5 is 1 by Z raised to 5 plus 1 by Z raised to 4 plus 2 by Z cube 2s square plus 3s 2s square plus 5 equal to 0. Simply replacing S by 1 by Z and replacing S by 1 by Z, now we get a new set of characteristic equation. The coefficients of Z are here 5, and then we are rearranging it from the highest order, and this is the new set of characteristic equation. We form the Routh array with the help of this in the similar way, but here since we can see that we have mentioned it as Z5, Z4, Z3, Z2, Z1 and Z0. So, now we are checking this with respect to the Z domain. So, here it is 5, 2, 5, 2 and 1, 5, 2 and 1. Similarly, arranging the second row and completing the Routh's tabulation, that is the Routh's array with the help of the coefficients. So, it can be seen that there is a sign change here, 3 minus 4 by 3, there is a sign positive to negative, and here negative to positive. So, there are two sign changes, that is 2 times the sign changes here. Therefore, the system is unstable, having two poles in the right half of the Z planes, because this we are inferring after replacing S by 1 by Z. So, that means that there are two sign changes in the Z domain in the Z plane. So, we can say that the number of roots in the S plane are, which is on the right hand side, is also 2. We will take the example for the special case 2. It is, consider the characteristic equation s raised to 5 plus 4s square plus 8s cube plus 8s square plus 7s plus 4. So, we are arranging the Routh array here. The coefficient of s raised to 5, the highest order term, then 8, then 7, 4, 8 and the value 4 here. So, the first and the second row are arranged with help of the characteristic equation. Then we go ahead with the Routh's tabulation. We get this value 4 into 8 minus 8 divided by 4 as 6, 4 into 7 minus 4 into 1 upon 4 is 6. Similarly, we get these two values 4 and 4, and then we can see that 4 into 6 minus 4 into 6 upon 4 is a 0 value. Here also 4 into 0, 6 into 0 upon 4 is a 0 value. 1, 2, 3, 4, 5th. The 5th row, we can see that the 5th row has prematurely terminated. We have not reached s raised to 0. However, when forming the table, we should have terminated at s raised to 0. We should have terminated at this point, but we can see that the premature termination has occurred at the s raised to 1 row. So, the step is to form the auxiliary equation preceding this row, that is preceding the row is this, the row preceding this is the preceding row, and then we can see that this is the auxiliary equation AS. AS is formed by, this is the term s square. So, we are going to write 4 s square, skipping the other one, it becomes 4 plus 4 equal to 0. So, as we had arranged with alternate coefficients, here also it is, the first one is for s square, that is 4 s square, where we are writing the preceding auxiliary equation plus 4 equal to 0. Then we take the derivative of this value, derivative of AS upon ds is, when you take the derivative, we get it as 8s plus 0. We are getting the derivative of as 8s plus 0. Next step is to continue with the Routh tabulation. See, here it is 4 and 4 and this row has become 0. Then what we do is, we keep this the same till here it is the same. Here for the s raised to 1 row we got a 0, we are going to replace it by the coefficients of the derivative with respect to s formed from the auxiliary equation, that is it is 8 and 0. Then we go ahead with the calculation. So, here we are not checking the sign, I mean we are checking the sign here and we can see that there are no sign changes. So, this implies that there are no sign changes, implies that there are no roots in the right half of the S plane, but if prematurely 0 appears in the complete row, that the complete row is having value of zeros, all the coefficients are 0, that means that there are roots on the j omega axis. So, that is to be checked. Since there are no sign changes, it indicates that the right half S plane has there are no roots in the right half of the S plane, but since we prematurely ended with the Routh tabulation, it means that there are roots on the j omega axis and the remaining roots whatever would be on the left half of the S plane. So, since there are no sign changes, we can infer that there are no roots on the right half of the S plane, and then to find what are the roots on the j omega axis, this itself indicates us that there are roots on the j omega axis because 0 appeared here. So, this indicates that there are roots on the j omega axis. Solving the auxiliary equation, we are going to solve this auxiliary equation to know what is the value of the roots which are lying on the j omega axis. The roots which are lying on the j omega axis are 1 and minus 1. So, these two roots are lying on the j omega axis and there are no roots on the right half of the S plane, no roots on RHS of S plane. So, the system under consideration is limitedly stable, that is marginally stable, because roots are lying on the j omega axis. So, here we have discussed the two cases, special cases of Routh Hurwitz criterion. Thank you.